Hello everyone, welcome to Code Space. In this video, we are going to learn about the traversing techniques of tree and graphs, the common traversing techniques of trees and graphs, that is BFS and DFS. First of all, DFS. DFS is depth first search. It means in this traversal technique, we start with a particular node and we go into the deep as we can to any side, like left side first or right side first. It's your choice that you can do go any side, but we go into the depth before backtracking. And once we visited all the nodes, we'll backtrack and we'll visit the nodes of the other side. For example, if we consider this tree, the depth first search will, if we start from the node A, then the depth first search will be from starts with node A. DFS of this graph will be first it will go to A and then it will go to B and then it will go to D. Now, once it reaches to D, there is no left node of D. So, and also there is no right node. So it will backtrack to the B node B. Now, when it backtracks to the node B, it will now visit the next children, that is E, and then after visiting E, again there are no right node and left node of the node E, so it will again backtrack to the node B and visit the next node, that is F. And hence once it completes all the child nodes of the node B, it will backtrack to the node A and go to the next child node of the node A, that is C. Then after C to G and then H and then I. So this is going to be the DFS of the given tree. Similarly, if we talk about depth first search, here for depth first search, deeper goes deeper deeper as possible. Whereas in the case of breadth first search, the tree or the graph is traversed level wise. It completes the first level and then goes to the next level, and then once completing all the nodes of the second level, it goes to the third level. So in the case of breadth first search, goes traversal technique goes level by level. For example, if we write the DFS of this DFS of this graph, that would be starting from A, it will visit the node A and then node B and then node C and then D, E, F, G, then after H and then I. And similarly, if we write the DFS of this graph in the same way, if we start from the node A, DFS will be note for graphs. Let me write that. For graphs, we'll maintain an extra array. We maintain an array done in which maintains the to maintain the status whether the node is visited or not, to ensure we does not stuck in a loop giving TLE. of each node. What I'm going to say is if you visited A and after visiting A, you go on to the node C, let's say, then when the C node you are visiting the all the children of the C node, A will also come again. And if you didn't maintain any status like I have already visited A, then you'll again start going to the node A, which ends up in a loop of going to A and then C, C to A to C, which gives you TLD. So to avoid this, we'll maintain a separate array done which maintains the status of each node, whether the node is visited or not. And once a node is visited, we does not traverse to that node anymore. And if we apply the DFS traversal of this graph, it would be A, then after C, and once the C node is executed, we go to B and B to G. After G, we'll go to E and we again backtrack to the node C and we visit node H and again we backtrack to node A and then we continue visiting the node F and I and then D. This is going to be the entire DFS traversal of this graph. And if we talk about the BFS traversal of the given graph, starting with node A, then first we'll visit A and then C, F, and then V, H, I, then G, then after E, and then we'll end this with D. This is going to be the DFS traversal of this graph. Let us talk about the implementation of DFS and the BFS. For example, if you want to implement any DFS, I'm just writing this pseudocode. You can convert this pseudocode in your language, in which your language you can want to convert. In DFS, we'll use the recursion in which in each recursion call, we make the DFS call of the current node. And in DFS traversal, we maintain a queue for storing all the adjacent nodes of the current node. Let me write the code, entire code in CPP. So in DFS, the DFS function will take the arguments node and the adjacency list along with the done vector. will traverse the entire adjacency list of the current node and apply the same DFS function for all its child nodes. Will pass again the child node as the current node and adjacency list and the done. And whenever we enter into this function, we'll make the done of the current node as one as we have visited that node. So we'll update its status to visited. Done of this node is equal to 1. So in this way, we're going to implement the DFS function. Let's write the implementation of BFS. As I told you that in BFS, we'll maintain a queue which gives the next edge that we are going to traverse in order to make it a level-wise traversal. For example, we'll, we'll run a while loop until the queue becomes empty. Empty of. Now, if the queue is not empty, we'll take the top edge. We'll take the top node, will top equal to queue dot top of. Now this will return a node that we have to traverse now. So we'll make the done of this top equal to 1. And here we are going to push all the adjacency nodes of this top node which are not visited. Like in the case of DFS also, we'll write a condition that if the child done of the child node, it ensures that the child node that you are considering as to be traversed will not be traversed before. It makes sure that you're taking the child nodes only which are not yet visited. So here also the same condition will take, like if the adjacency list of this top node, will write this in a for loop. We're just traversing all the nodes of this top. Let me write auto child ADJ of the top. We're traversing all the child nodes of the top node, and if the child node is not yet visited, that is done of child node, child is equal to 0, then we are going to push that into the queue. Q dot push child child. Now after completing the adjacency nodes of the top node, we are just pop out the top node as we have already listed it. So for this will the BFS will start by pushing the first node by which you are going to start your traversing. Like in this examples, we have took the node A. So here in this case, we'll push the node A. to start our BFS traversal from the node A. Similarly, in the case of DFS, if you want to start from node A, you just make a call starting with the node A along with the adjacency list and the done vector. This is the implementation of DFS and BFS in CPP. I hope you get a clear idea on how the traversal techniques is implemented and how this algorithm is actually working. And that's all for today. I hope you like this video. And if you liked it, please hit the like button and subscribe to our channel to get the related coding related contents regularly and keep your placement preparation up to the mark. I hope you will get placed in a very big company. Thank you for watching. Goodbye.